Hello everyone. Previously I already made a tutorial video for this subject where I use a PC as a supervisory controller of two RPi combined with CM50 robots. But this is it was using Python or code. But this is version 2 now, the latest version. So I'm going to describe the two robots. I call the Enhanced Pencil Commando and RPi4B+CM-550 or Articulated 4-Wheel Platform, the H version. The PC will be used as a supervisory controller of both robots and is using Bluetooth. So this is what the EPT look like. In this mode, the pen tilt servo and the Pi camera are controlled directly by the RPi4B. The DMS-80s and the wheel servo are controlled by the CM-550. So let's look at how the communication line works between PC and the APTC and the robot. So the desktop will send remote packet via the Bluetooth to the RPi4B. The RPi4B controls its own Pi camera. It also controls that two pen tilt servo. It's using Dynamics SDK packet for that purpose. It also sends remote packet via USB wire DTI ACM0 to the CM-550. So when the RPi4B decided that the robot need to go forward, backward, left, or right, it sends those kind of commands to the CM-550. And the CM-550 then take care of its own wheels. The CM-50 also taking care of DMS-80. So let's say that it's moving around and there's an obstacle nearby blocking its sensor, and then what it does is will send signal. It will take care of the avoiding the obstacle on its own. It also sends a signal of the IMU, actually just the UART data, back to the PC through the BT210. Okay, so the articulated 4-wheel platform here, you can see also have RPi4B here. This one is a little bit different. So we have 8 servo goal position, set in goal position mode, and 4 wheel servos. And they're all controlled by the RPi4B, including the Pi camera, of course. And because the Pi camera is attached to the body of this robot, somehow we have to move the camera up and down, and that's due by moving the body. So the front leg will walk, so motion unit, except we don't use motion unit now. I will tell you differently in a little bit. And then it's also help in tilting the body up and down. The rear leg pretty much stay fixed, and it's used only for the body tilting function only. In this particular case, the CM-550 is only controlling the DMS-80s and the buzzer. Okay, so how our communication line now. Desktop still send remote packet via BT to RPi4B. RPi4B control Pi camera. RPi4B control up to 12 of those XL430 using Dynamics SDK packets. Now 8 of them are under the new mode, so-called time control, that is new for the XL430. And then I don't need motion unit like I did from the motion tool anymore, but I put them into, shall we say, motion array, and I use time control to do the walking and other things like that for goal positioning. The CM-550 it only controls its DMS-80 and the buzzer now, but it's active control, shall we say. So we'll monitor its DMS-80 and see if it's an obstacle. It will send a command to the RPi4B, tell it, hey, you need to move the robot back, forth, left, right to avoid the obstacle that I am seeing here. So they are sharing into the computing load here. And that's doing through remote packet also. And I'm using an LN101, so basically a wire go through the UART port. And remaining, I'm using the embedded BT410 on the CM-550 to send console printing, to send data on the your angle of the IMU back to the desktop PC. Okay, so let's look at the details here. So at runtime, I tested just one robot at a time first. So this is the window of Funny. There's a code that is doing the supervisory control on the PC side. This is what it looks like. So it has a little icon. You can turn it on. If it's bright, it means that it's under right now the PC is controlling the EPTC. The R4B+CM-550 is dark. I mean, it's not, the PC is not controlling this robot. And here is a VNC view of the RPi desktop. You can see that I'm running a C code. I'm using AFCOM0, opening it, and right now it's tracking that red ball there. So there's data coming through here. Also, I have a small application where the CM550 will send its yaw angle and it display in the little monitor down here, in the little window down here. So I have played with this thing, just one robot. I can get 15-20 minutes out of play of this system without any problem. For the R4B+CM-550, I did similar thing. I tested on its own only, and you can see I got everything working okay. I can get 15-20 minutes out of play of it without any problem. This here is tracking. You can see it's tracking a yellow ball, and it's doing its job okay. So I say, okay, let's put all of them together now. Let's have the PC running that Python code on the PC, and let's control both robots together and see what we can do. So this is the window for the Python code on the PC. This is a little webcam view, so you can see that the R4B+CM is tracking a green ball and the EPTC tracking a blue ball. And here is the VNC view into the desktop of that RPi. You see it's tracking here and the display and stuff like that. So this one is tracking the green ball. And then you also have two data screens from each of the robots sending the yaw angle data through here at all time here also. Okay. So let's ready now and let's see what we can do in real time. Okay. So this one here is the Python code on the PC. That's the doing the supervisory control on the PC. It right now is already running, and when it runs, it keep on sending probe. Basically, just probe data, probe packet. They don't control anything. It's just probe packet to keep the communication line going between the Bluetooth and both ends to each of the robot here. Okay, and then because at that time the CM550 is already running code, so you're gonna see the yaw angle over here. They're gonna change when I start the video. It changed all the time here, so that part is totally good. The little webcam view. Okay, so first right now is you cannot see because the numbers are too small, but I've gone in and pick out the try to extract the color properties of the blue ball here on the EPTC, and also extracting out the color property of the green ball here on the R4B+CM program. Okay, but they haven't put them into tracking mode yet. When I start the video, you see I'm gonna put first the EPT into tracking mode with this one, and you can see it will go back and forth trying to adjust and center, keep the ball centered. And then I'm going to switch to controlling the R4B+CM just by itself, not with take this one off of the supervisory control. And then later I'm going to put both of them together and trying to move both of them together, and you can see. Okay, so let's go now. You can see CM550 is working, so I keep on running that. You can see the angle changes. The supervisory control code on the PC also keep on sending that probe packet over, so you see this one is updating all the time. Now I just enable the tracking on the EPTC. You see it go back and forth trying to do that. Right now the speed setting on it is a little bit too high for the rate of flow of the data coming in, so that mismatch of that, so you can see it basically right now, although you see it's not bad here, but it's kind of too slow for you see how it's changing. And then okay, I just put the RPi4B under. You can see it go back forward, go up and down. Sometimes it runs the wheels only to see it, to try to get it going. This one adjust here a little bit because of the light flickering a little bit. It will change, it will adjust itself. So I'm going to just go physically bump it over. You see it react, and react mainly this one here, moving the body, also moving the camera. So right now, so both of them are on. So I'm going to do, let's see, I think I'm going to turn off one of them. So yeah, I'm going to just turn off, how to turn off the RPi4 from the control. And I just move this one a little bit. You can see it react. So the EPTC is pretty decent when you disturb it, and it will try to stay in this auto tracking mode very well. So here I move it too much over here because the program made it so when they don't see anything, it just stops. So I move it back. This is I manually go through the PC, move it back. Here I'm doing too good. I stop when it's centered, so I adjust it again. Okay, it coming back. Adjust the camera. So now I'm pulling it back manually. Through the SC control, system control, pulling it back. And when I release that, you can see it go back on it, and it keep on adjusting. It's trying to keep things centered and of a certain size. You see, so it's doing well there. Okay, so I'm going to switch to the walking bot, the RPi4B+CM-550, and then I'm trying to push it. I'm going to move it backwards. To say you're going to see quickly there is a command to send it back in here. Yep. So I went up to decide to turn this one off and just adjusting this guy only. Okay, here we go. Let's see. Oh, okay, I just send the data to move it backward. You see it's moving backward. And then we're trying to go forward again, trying to adjust. So it's doing its stuff. So you can see, a walking robot is not good for tracking any object because it moves around, jerking around too much. Now I put in back both of them together, and when I send a command, it disturbs both of them. You can see, as usual, the EPTC will do well and adjust itself to be responsive. This guy is still struggling, moving around. Okay. Here we go. So I just move it to the left, and the reactor coming in. So wheel platform is best to track color like this, as everybody knows. Now there's something going wrong. At this point here, everybody froze. I have no idea what happened. Both of them froze, and this guy, because it happened to be drifting forward when everything froze, so it went up. It almost flipped up the table, so I grab it, pull it back, and then that woke that guy up, and now he's tracking. So EPTC is tracking again, but I still have no command or no control over RPi4B, and then boom, I just lost my Wi-Fi connection between the VNCU, the PC, and this robot here. So that's it. So at least for about 3.5 glorious minutes, I got control of both robot, and everything is working as programmed. So that's it. Until next time.